Good day to our beloved students. Welcome to our math class. It's a great pleasure for me to teach you and give you the learnings needed for our today's lesson. Our objective is to prove the Pythagorean Theorem. Are you ready to further understand the lesson? Okay, let's get started. Our lesson is to prove the Pythagorean Theorem. In this lesson, you will learn the relationship among the sides of right triangle as expressed in Pythagorean theorem is often to be used to calculate distances in real-life problems. Before we start our discussion, let's try to fill the blanks with the missing term or terms for each statement. In number 1, a polygon consisting of 3 sides is called. If your answer is triangle, you are correct. For the next number, triangle with right angle is called. Can you guess the correct answer? If your answer is right triangle, then you got the right answer. For number 3, the longest side of a right triangle is called the hypotenuse. And for the last number, the other two sides of a right triangle are called. I'll give you a hint. They are parts of our body that starts with letter L and consists of 4 letters. Can you now give the answer? If your answer is legs, congratulations! That's the correct answer. Now let us analyze carefully the given figure at the right and name the following. What kind of triangle is this? The given figure is a right triangle. Can you name the hypotenuse of the given right triangle? The hypotenuse is side C. How about the shortest side? The shortest side is side B. Next, how about the longer side? The longer side is side A. And last, can you name the right angle of the given right triangle? The right angle is angle ACB, or it can also be called angle BCA. Now that we have familiarized with the parts of the right triangle, let us now discuss about the Pythagorean Theorem. According to the Pythagorean Theorem, in a right triangle, the square of the hypotenuse is equal to the sum of the squares of the lengths of its two sides. If C is the hypotenuse of a right triangle and A and B are its legs, therefore, C squared is equal to A squared plus B squared. For us to prove how Pythagorean theorem works, let us answer this first example. For us to prove that Pythagorean theorem works, let us answer this first example. In a right triangle with the length of sides where A is equals to 3, B is equals to 4, and C is equals to 5, let us prove that the square of the hypotenuse is equal to the sum of the square of the legs. Before we proceed, let us take note that the hypotenuse is the longest side of a right triangle. Also, hypotenuse is the opposite side of the right triangle. To prove that the square of hypotenuse is equal to the sum of the squares of the legs, we use the Pythagorean formula C square is equal to A square plus B square. Then, let us substitute the given lengths of the sides of the right triangle to the equation C square is equal to A square plus B square. Substituting the lengths, we have 5 square is equal to 3 square plus 4 square. Getting the square of the lengths of the sides of the triangle, we have 25 is equals to 9 plus 16. Simplifying, we have 25 is equals to 25. Since the left side and the right side of the equation is equal to each other, therefore, it is true. Square of the hypotenuse is equal to the sum of the squares of the legs of the right triangle. For our second example, let us prove that 13 is the hypotenuse of a right triangle which lengths of legs are 5 and 12. To prove that 13 is the hypotenuse of a right triangle which lengths of legs are 5 and 12, let us use the Pythagorean formula c squared is equals to a squared plus b squared. Then, let us substitute the length of the hypotenuse, which is 13, and the lengths of the legs of the right triangle, which are 5 and 12. Substituting, we have 13 squared is equals to 5 squared plus 12 squared. Getting the square of the lengths of the sides of the triangle, we have 169 is equals to 25 plus 144. Simplifying, we have 169 is equals to 169. Since the left side and the right side of the equation is equal to each other, therefore, it is true that 13 is the hypotenuse of a right triangle which lengths of legs are 5 and 12. Since we have already proved that the Pythagorean theorem is accurate and true, let us use the Pythagorean formula c squared is equal to a squared plus b squared in finding the measures of the missing side of a right triangle given the lengths of its two sides. For our example, if one leg of a right triangle is 4 and the hypotenuse is 5, find the measure of the other leg of the right triangle. To answer this problem, let us use the Pythagorean formula c squared is equals to a squared plus b squared, in which c is the hypotenuse and a and b are the two legs of the right triangle. Then, we substitute the length of the hypotenuse, which is 5, and the length of one of the leg of the right triangle, which is 4, to the Pythagorean formula. Substituting, we have 5 squared is equal to a squared plus b squared. Take note that you can use a or b to substitute for the unknown length of a leg of a given right triangle. Then we get the square of all the sides of the triangle. Doing so, we have 25 is equals to a squared plus 16. Since we have to isolate the unknown on one side of the equation, we add negative 16 on both sides of the equation. Simplifying, we have 9 is equals to a squared. Then, we get the square roots of both sides of the equation. Solving, we have 3 is equals to a. Therefore, 3 is the measure of the length of the leg of a right triangle whose hypotenuse is 5 and the measure of the other leg is 4. For example number 4, what is the length of the hypotenuse if the legs of a right triangle is 6 and 8? To solve this given problem, we use the Pythagorean formula c squared is equals to a squared plus b squared. Then, we substitute the lengths of the legs of the right triangle to the equation, giving us c squared is equals to 6 squared plus 8 squared. Next, we get the square of all the sides of the right triangle. So we have c squared is equals to 36 plus 64, or c squared is equals to 100. Then, get the square root of both sides of the equation. Simplifying, we have Square root of c squared is equals to square root of 100. C is equals to 10. Therefore, 10 is the length of the hypotenuse of a right triangle whose legs measure 6 and 8. So, those are the examples on how to prove Pythagorean Theorem. To sum up the lesson, remember that the Pythagorean Theorem states that in a right triangle, the square of the hypotenuse is equal to the sum of the squares of the lengths of its legs. Take note that the hypotenuse is the longest side of a right triangle, and the hypotenuse is opposite side of the right angle. So that ends our lesson on proving the Pythagorean Theorem. I hope that you enjoy and understand the lesson that we have discussed clearly. If not, you may go back to the lesson presented. If the lesson is clear to you, congratulations! You may now proceed in answering the exercises given to you in your module. Again, this is Mr. Herbert Evangelista saying good luck, God bless, and enjoy learning. See ya!